Meteorologist Tuttle here with you. Glad to have you on this Tuesday evening. As you can tell, I've been a lot more active with more weather updates because we've had interesting weather set up. We're going to get to the details on that tonight. I'm going to tell you what's changed or what hasn't, give you the reasons as to why we're in this predicament. And what we're talking about is a ice storm that'll be developing here across parts of Oklahoma. So I'll show you the most likely areas for that, and right now our best guess at total precipitation amounts, including total ice amounts. So here we go. Hey, by the way, make sure you like the video, comment. The more you interact with Facebook, the more Facebook will have a tendency to notify you when I go live. And make sure if you haven't done so, click the bell at the top on Facebook and on YouTube to get notified. That way it works out a little better, not a guarantee. For that purpose, I've got my Facebook fan subscriptions and Patreon. If you join those two membership deals, I'll give you an inside private Facebook page, a group page where you'll get notified there a lot better. And I share the same content plus a little bit more. That way you don't miss anything. The description will give you all the information, the links on that you can time into at any point during this broadcast or when you're about to sign off. Just click that and you get the details. So there's many ways to follow me here, by the way. If you're new, I cover social media, so I should have you covered pretty much every account. The first thing I'll tell you is one of the new things I added was this is on Twitter. So on Twitter you can follow me, which ties into Periscope now. Still have my YouTube, so you can join in at Aaron Tuttle OK, which is short for Oklahoma. And that's my YouTube channel. You can watch me there. And of course the main page here on Facebook. And this is my private Facebook page. So there's many ways here to get this. Plus, last but not least, my website. This is AaronTuttleWeather.com. And if we do a little refresh on here, you'll see a couple things here. One, the YouTube chat is embedded on my website. So you can go here if you want instead of the YouTube app and have your chat back and forth just like you would on Facebook. And you can watch the live video here. And so that's also an option. This is available through my weather app, which is AT's Weather to Go. And if you haven't checked out the website, you're missing out because there's all kinds of weather information on here. There's a flu report, earthquakes, drought conditions, radar maps, Oklahoma Mesonet, power outages, road conditions, you name it, I got you covered. So make sure you visit this often, and that'll help you out when you plan around the weather. Okay, so let's get on with it, shall we? Interesting setup of events here. So what I'm going to show you, the first thing is a comparison of the model data from just a couple of days ago. Actually, just a few runs ago. I mean, not necessarily a couple of days ago. It's on the 13th. So in the morning of the 13th. So about 36-hour difference. I want to show you why the models are starting to catch on to this idea of an ice storm. And what we talked about all this in prior conversations. So this is the upper levels energy in the atmosphere. This is the jet stream pattern. We have a trough coming in to the west, which creates an upper level area of lower heights. We say low pressure because it's easier to understand than low heights. It's a drop in the field. But what happens is it causes surface pressure to develop across eastern Colorado. What we also have down here is a weaker upper level low that's never detected well in the model data because there's no observations down here. We can't get balloon soundings. We have to use satellite to estimate. So it's always going to be a little underestimated. So that's one of the weaknesses in the model. All right. So just kind of give you that heads up. Now, this is a snapshot in time, a forecast period for Thursday evening at 6 o'clock. I want to show you where the position of this stuff is. Show you in Oklahoma, the instability is highlighted here in the brighter red colors. Now what I'm going to do is fast forward, same time period. In other words, this is still going to be for Thursday evening, but the model that just came out just now. And you see the difference? The low here lifted north and west, and the energy here increased in strength. So what happens is the model's finally getting a clue that this stuff down here means business. That means a lot of rainfall. It also means that this guy coming a little weaker and further west means the low out here won't be as strong. What that means is it's going to pick up on the temperatures a lot better and start to produce more ice as an outcome. We can also look at the vertical velocity. This is the lift in the mid-levels atmosphere. It really wrings out the moisture. Again, all the red indicates extreme lift across Oklahoma. And for that same time period, 6 o'clock on Thursday, there's a little bit in Oklahoma, but not a whole lot. Now, you take the same model, you take it that just ran here this evening, and all of a sudden, what is all this? Woo, that's a lot of red. That's a lot of lift in the atmosphere. It means a lot of moisture getting squeezed out of the cloud cover and the instability that's present, which means more totals on the rainfall buckets, or in this case, ice accumulations. So those are the main differences that we're seeing in the energy part of the atmosphere. Now I'm going to tell you the temperature part of the atmosphere and show you what it's doing. And this is all to set the tone as to why I kind of warned about this scenario unfolding, how the models wouldn't see it until the last minute, and this is kind of what's happening. So right now, 39 degrees is the temperature it had for Thursday afternoon. All right, that's the old run. The new run now has 33, 32, right here in Oklahoma City. That's not good, just to let you know. So that is when I say we're on the very edge of this potential ice field here in Oklahoma City. And every run that comes in, it trends wetter and colder. You don't want to see either of those. But that's what's happening, and that's what's expected in this type of an outcome. So I want to get you up to date as far as how the models are starting to catch a clue, which means you're going to see all your local forecasts start to change because you'll have everybody reacting to the model data versus trying to out-forecast the model data. This is one of those situations where you have to kind of get out ahead of it because it'll come out to bite you and then you're playing catch-up the whole time. Now that said, these are tricky situations in the wintertime. A degree or two matters. So even if I stick with an ice storm and all the models go ice storm, if we warm to 33 degrees, it is just a very cold rain. And we're going to be real close in some areas where it matters. So let's show you where that's going to be. Here's a short range model. These are our models that we use for very high resolution data, but typically for severe weather because they get the temperature and the dew point very accurately. All right, well, let's see this little red on the map. That's ice. The blue is, or the purple is sleet, which is those little pebbles, those little grains of clear balls you see falling from the sky. So that's here in central Oklahoma. That's Canadian County, that's Oklahoma County, that means Oklahoma City, it's Newcastle, all the way stretching down to southwest Oklahoma, again by Thursday evening. So this is a developing storm during the day on Thursday. Another one of these high resolution models picks the same thing, but it's got a little bit more of it shifted here to the north, but still includes central Oklahoma. Now this is all new. They're just now kind of getting into the 48-hour time span where they can actually pick up on this stuff. This one here keeps the bulk of it out to the west as it delays the onset of precip a bit and just shifts it just west of Oklahoma City. All right, so there's three of our best high-resolution models showing you what the potential outcome is going to be. Now, when you look at some of these other models that can accumulate the ice, this is the Canadian model, the short version of it, which only goes out to 48 hours. So it won't include Thursday night. It'll stop at 6 p.m. Thursday, I believe. Yeah. So it's continuing with its hot spot here just on the western sides of Canadian County. So Kingfisher out toward Weatherford, and it already has about a half inch of ice in this particular part. And again, we're talking about freezing rain, which is rain that freezes on contact once it hits the ground. If we look at the NAM model, or no, this is the GFS model. This is the American model. It's been wavering back and forth all over the place. All right, it's had ice over here, and then it's had ice over here, and then it's had ice over here, and it's had ice down here. It doesn't know what to do. All right, but that's typical. American model is horrible at winter weather icing events anyway, so I'm not surprised that the newer version of this model still stinks. But regardless, it's still showing ice on the map. So the take home so far that you can see is a guarantee outcome here in the western third of the state. The question is, how close does it get to Oklahoma City metro area? Here's our latest version of the NAM. This just came out this evening. This is kind of the one I showed you on the big map to show you the difference, how it's playing catch up. This is the close-up view of that with the ice accumulations. And this purple area is anywhere from a ½ inch to 3/4 of an inch of ice. Now that is in Canadian County. Now notice it puts the breaks right here in the county line between Oklahoma County and Canadian County. That's the big difference between Oklahoma City Metro. That means cold rain, Oklahoma City downtown, and that means ice storm in El Reno. It is going to come down to something like that, folks. And for me to be able to tell you tonight, that fine line is impossible. Hopefully, tomorrow night we'll have a better idea. But this far out, all I can do is give you the general area. And right now it's touch and go here in Oklahoma City. And out west is where most of the action is. And it's just barely out west. That does not mean it will not happen here. Some models are indicating that it will. I'm going to show you the reason for that. Now, this is where I get technical. So hang on. We're going to go in the upper levels of the atmosphere. I'm going to show you some cool stuff. All right. This is a look at a sounding. You guys normally don't get to see this, but this is the cool stuff. that I like to show. And I'm going to show you how we get to the situation where you're talking about, let's see, let's do this. Let me shrink this bad boy. Can I shrink it? Stand by. Come on, you let me shrink this. Don't you be like that. Why would you do that to me? You're going to do that to me. All right, there we go. Okay, I just had to move it up a little bit. Barely cover that. Okay. Oh, you did it again. Get in there. Okay, barely got it. Whew. All right, it's right above my banner. We're looking at this line right here. This is a freezing line that goes up in the atmosphere. All right. This is the surface right down here at the bottom. So this would be several thousand feet as you keep climbing up, 25, 35, 40,000 feet all up in there. Got it? So what we're looking at is the surface temperature and the profile, which is temperature and dew point, the red line and green line. Red line temperature, green line dew point. So this is where we're getting into some geeky meteorologies. Hang with me. It's all going to make sense here in a second. What happens is these two lines are close. That's moisture. It's cloud cover. It's rainfall. When they're further apart, that's dry air to overcome. So this rain will come through this dry air and then start to saturate it, and that's how we start to get the rainfall. This is at noontime on Thursday here in Oklahoma City. So in other words, we're going to have cloud cover. It's going to be raining aloft. It's going to be evaporating before it hits the ground. But over time, as you saw, that energy in the upper levels continues to come in later in the afternoon and evening. This will take over, and this will all be turned into liquid. Now, what you can see is this blue line, which is our wet bulb temperature, is below freezing. So that's when the dew point and the temperature come together once the air is saturated. And what happens as we go through time, let's head on into, this is 6 o'clock, 7 o'clock, 8 o'clock, 8 o'clock. We'll pick 8 o'clock. All right, the atmosphere is basically saturated. We've got the rainfall. Model says rain. And we're right at like 32.1 degrees in Oklahoma City. That's how close it has for the ice. I'm telling you, that's why this can be a nightmare for forecasting. Okay, this is what it looks like on a two-dimensional view. If I were to take a snapshot of the atmosphere and slice it right down the front, and you're just looking at a flat plane of it, you have to visualize this is all the cloud cover, several thousand feet up, all the way down the surface. Okay. This right here, these green lines represent accumulated rainfall every quarter of an inch, or every quarter hour to half hour. It's got about an inch of rain here in Oklahoma City. All right, so this is just an inch of rain, which means at 32.1 degrees, and then slowly climbing on into Friday morning and thereon, it just keeps it all rain. So no ice at all. Whew, right, close call. So this is just an example of how close that can be. Now I'm going to show you a site up around Kingfisher. Same principle, same idea. When I calculate the ice amounts here, they turn red, which means it's not green for rain, it's red for ice. It's got 0.4 tenths of solid freezing rain. Now we have a new thing in the model that we can look at that will accumulate on round surfaces, such as power lines. This model particularly says 0.16. In other words, less than a quarter of an inch of ice on any round surfaces like power lines or tree limbs. Flat surfaces, you'd get more closer to the thicker variety that doesn't run off. Now, what that becomes crucial is because once you get around a quarter of an inch of ice, that's the weight that starts to get those power outages going. And this is the event here for Kingfisher area. Now, this is just one model, one snapshot, but it gives you the idea of the difference between two areas of central Oklahoma. East side, just above freezing. West, obviously below freezing. And then you get the ice accumulation. So this is a lot of the tools we can use in the weather business to find out what we're in for. Let me see if anything new has come in since I've been talking with you. Let's see. Okay, so the GFS had just come in. Remember I told you earlier it's all over the place most of the time. So let's see what it's done with the ice amounts. And we'll see if it's still all over the place or if it's starting to settle down. And this is going to be a comparison run. So let's go 60 hours. Matter of fact, let's just go 72. So that'll take us through Friday, so that'll cover the folks up around Kansas and Missouri. All right, so it's now becoming settled down. If I look at the last run, the run before, it's settling down into the same quadrant. Last 3 runs are lining up here, southwest and northeast in this region. So from Ponca City southward to El Reno, southward to west of Lawton, west of Frederick basically, and then into the Texas Panhandle, and points northward for ice accumulations. Now the amounts, it's going to struggle with the amounts. This model doesn't have the ability to see as much vertical lift as the other model does. It's different physics, so it's going to have lighter amounts. I wouldn't necessarily agree with these lighter amounts, but at least the placement, it's settling down and it's got the general idea. And then of course more ice up here and some sleet mixed in across this whole area, which they just had ice for Kansas and Missouri and Iowa just not too long ago. So they don't want any more of that. But it looks like they're going to get more with this system, and probably even heavier amounts too. So that's a quick look at the American model that just came out here just a moment ago. Whew. So bottom line, prepare for the worst, but hope for the best. Temperatures will be very crucial here in the greater Oklahoma City area. It can go either way at this point. I would lead toward caution and say, you know what, just bet on having some ice here, and then if we warm up a degree or two, thank your lucky stars, because just west they will not be in that situation. They're going to be in the below freezing point, and then we'll have to see how much accumulates over that period of time from roughly noon Thursday. That would be the very earliest start likely, because it'll take a while to saturate the lower parts of the atmosphere as I showed you. But then it's going to kick up as we head into Thursday evening. Most activity moving out by, we'll call it mid-morning Friday into the lunchtime hour. And as far as the ice potential goes, the other good news I had, and I'll explain this in prior videos, is we'll have a tendency to warm, which means we're going to erode the Arctic air mass. It's about 1,500 feet thick. Now the latest model gets a little thicker, closer to 2,000 feet. The thicker that cold air, Arctic air is, the harder it is to erode. A layer that's about 500 feet thick, a lot easier and quicker to erode. One that's 2,000 feet thick or 2,500 feet thick, it's going to take some time. Now, what will happen is, as the rain falls, it'll help to kind of warm that area a little bit, believe it or not. Initially, it cools it, but then over time, with latent heat releasing, it'll warm things up, and we'll get a southerly wind back in here, which will bring in warm air from Texas. Now, a lot of that warm air will override the cold air originally, but at the leading edge, will kind of keep eating away at it. So we'll eventually get better as we head throughout the day on Friday, at least over central Oklahoma. I can't guarantee that in northwestern Oklahoma, and that's why ice amounts are going to be a little heavier in that area, whereas we might just be lighter. So a possible outcome of this point in time would be the freezing rain during the day on latter part of Thursday into Thursday night, so travel problems obviously into Friday morning. So that means Oklahoma City on the table here is an icy commute for your morning drive on Friday. And then all of a sudden, by 9 o'clock or 10 o'clock, we warm above freezing, and it's raining and sweat, and the ice is gone. That's an easy outcome that I could foresee. We're just going to have to wait and see. But look, I'm giving you the best forecast you can get with the best model data that we've got, and that's what we have to work with. So weather is not an exact science. It's an inexact science for a reason. Yes, it's kind of like playing doctor, and the models are infallible. So they're not going to get it right every time, and they'll kind of give you the idea, kind of help guide you in some cases. In other cases, you're just going to throw them away. So that's kind of where we are with this particular situation, at least early on. Now they're starting to play catch up, and we'll see where they end up kind of leveling out. But as you know, let's see, for the snow event, they did really well on the timing. They did really well on the general pattern. They did really well on the fact we're going to see snow. What they stunk at was the amount of snow. But you've known that if you've listened to me long enough. We show you those snowfall maps, and I'm always telling you a grain of salt, but this is the potential. And the potential is always there. It's going to be realized. And that functions on the track and a lot of other crazy things that happen at the last minute that the models will never see. And so it's very hard to get snowfall totals correct. Ice amounts is a different animal because we're not trying to change the state of the atmosphere and keep it like all snow. We're just talking about rain, and models do a much better job of just rain. The only difference is what they don't know typically is that last 1,000 feet or so, it's cold enough to where it just freezes on contact. It's kind of like flash freezing, and that's what freezing rain is. It's a mouthful. We covered a lot in about 15 minutes. Hope that was educational, informative. Hope that answered a lot of your questions, that kind of deal. So speaking of, if you had any questions, I'll ask you to hold those during the discussion part, and then at the end you can fire away, and I'll try to answer a few of them. Let's see. Just checked the Twitter account, and now I'm checking YouTube. And let's see. Now we're going to go to my Patreon page on my closed group Facebook page. It's always good to see my friends joining in, by the way. Thanks for you guys' support. A lot of you out there. That's good. Let's see here. I love the fact you guys communicate with each other, because a lot of you will jump on in late and you'll be like, what do you say? And then you guys will fill in. So I really appreciate that, by the way. You helping me out with that, because there's a lot to say, and to condense it, I feel sorry for the guys on the news, and you have to condense everything into 3 minutes. And as you just saw, it ain't easy. The weather is not easy in situations like this. And so with this format, you get to get behind the scenes of what a meteorologist has to go through, the thought process, some of the stuff they look at, and then that way you can realize, you know what, you guys actually have it hard sometimes. So there's a lot riding on this. Especially when you call for an ice storm several days away and you're the only one. Take some cojones. Don't look that word up, kids. Just ask your parents. They will tell you it means bravery. All right, let's go down to the Facebook page real quick. If you guys had questions, you'll have to repeat them. I can only go up so far. So if you're trying to travel, okay, so that's a good question. Let's see. Denise wanted to know traveling on Saturday morning to Dallas. Your only travel problem will be Thursday afternoon, Thursday night. Bridges and overpasses always first to go. Then, depending on how things go, slick spots on area roadways, that black ice kind of stuff, or, you've been forewarned. If you're out traveling, you already know the potential's there. You're going to have to be careful. Now, once you head into Friday itself, if you live in a central Oklahoma, south or east, Tulsa, all that stuff, you should be fine come mid-Friday morning onward. It's before that, here in central Oklahoma is where early Friday morning might be a problem. I don't foresee any problem in Tulsa or eastern Oklahoma or southeast or southern Oklahoma, okay? So you guys are in the clear. It's the western and northwestern parts of the state for Friday morning in the midday or even lunchtime before things start to moderate and warm up. And that's if that even happens. There might be some areas that stay right at 32 or a degree below. It'll be kind of a close call for moderating up there. So I envy, though, other weather guys, I'll say, those without a degree, and the meteorologists, those with the degree, because we're all looking at the same data, and you gotta pick a side. Normally, being conservative is good. On a situation like this, however, since it's such a dramatic outcome, if you just say rain, there's a lot of people that be watching that's going to get screwed over. So that's why you have to err on the side of caution and just say, look, man, it looks like ice. I'm going to go with ice. And if it turns out, like I said, it turns out to be 33 degrees, then praise Jesus, because we dodged a bullet. Because the potential is there, and it's not pretty. You know what ice storms look like. You know what power outages look like. The good news is, at least, it's not be one of those deals where we're trapped in days and days of below freezing temperatures and the ice never melts or goes anywhere. This won't be one of those things. Most of it here, at least anything that happens in central Oklahoma, will be back to liquid by mid-morning Friday. And then northwest Oklahoma, it may take until Saturday before all that's completely gone. In some areas, because the storm system will clear us out for Saturday. It'll still be cold and windy, but it should be above freezing still, at least. So things look good after that. But there you go. So Brandy, as far as kids going to school, too early to call at this point in time. They'll all call it Friday morning. They're going to see, what the temperatures do Thursday night, Thursday evening. So probably 10 o'clock on the news is when they're going to call it by that point. And, western Oklahoma, probably a no-brainer. Central Oklahoma, going to play it by ear, depending on where you live. So Matthew wants to know about Joplin, Missouri. So we showed a map up there. that, let me just take a peek. Yeah, it looks like you're just right there on the edge. I mean, you're just like Oklahoma City. Go either way. That warm air kind of hangs in there. So your local guys that are better trained in the terrain, because there's a lot of terrain that can change just from one county to the next in that part of the state, where cold air likes to dam. We call it the Ozarks, by the way. So if those guys are at least educated and they have history and some knowledge and experience in that department, they'll be able to better answer a specific location in Southwest Missouri. But as far as general trends and the model data, you're right on the cuff. So we can go either way, just looking at the data at that point. So that's where sometimes the local influences, terrain and stuff, can really change things. Just so you know there. All right, let me look again. I got a few minutes, so I'm just going to kind of keep scanning through. You guys that are already worried about Steve Miller. You're funny. Hey, Paul. So you guys are funny, though, asking already about spring, worried about tornadoes. Hey, y'all just get through winter first. There's plenty of time to worry about tornadoes. Only Oklahoma, though, can you be worried about tornadoes already, and spring is still 3 months away. Which, by the way, we should have a late start to spring. Long-range pattern keeps this winter weather nonsense going on into March, since we got a late start. The models promised us some cold weather for December initially, and then they held it off until January, the latter part of January. So we're finally realizing that. All right. Jody, you're keeping those folks entertained. Canadian girls on top of it. I tell you what, those Canadians are in tune with the weather. Oklahoma, you guys have some competition. They are so in tune with the weather up there because, my goodness, who would want to live there? Look, as much as we complain about our weather, dude, minus 30, that's for the birds. And that's not even a wind chill. Screw that. I got no desire to live in that nonsense. I feel sorry for those that do. Oof. So, Brett, it's possible. You get a quarter to half inch ice, sure. Anything's power outage is possible anytime you get that kind of ice totals. But like I said, it'll be a short-lived event if it happens here in Oklahoma City, and thankfully, over a highly populated, dense electric grid. So, but we'll see. This is only Tuesday night. We got time to iron out the details. And I'm telling you, it's just like this snow. Models could be all in for ice tonight, and then we go into Wednesday night update, and all of a sudden they back off, and they push it way west. They could easily pull that nonsense because they're going to struggle. They're trying to find out where the Arctic is, the Arctic air mass is. They got to find out how cold and dense it's going to be. And a lot of times, old school meteorology, I'll tell you a trick. Old school meteorology is the following. The morning of the event. So like Thursday, for example. Or let's say we'll go the night before. We'll give it 24 hours. So we'll say Wednesday night. It's better though on a morning sounding. So we would go, it really would be the morning of the event. I'll tell you what, but we'll go Wednesday morning for this purpose. Because that'll give the air time to get down here. You look at morning soundings of the balloon that the National Weather Service launches at all the different sites. And what you do is you take those morning soundings and you get the actual profile. We just showed you a sounding here in the model data, but you get the actual sounding in reality and real time. And you take a look at that plot. And then you take the model. We'll use a high-res model. We'll call it the NAM. We'll take that model and we'll see how it compared. Did it currently, accurately identify a snapshot of the morning? How off was it? Did it get the depth of the cold air? Did it actually get the temperature profile correct? So you do that from the northern end, we'll call it North Dakota, all the way down to the edge of the Arctic air mass. And you'll take it step by step by step. And you'll see if the model's on track. Then what happens is, if the model's off by, surface temperature, let's say it's off by 5 degrees. So what you do is you take that error and you multiply that forward in time and then distance down south. And so it's a little trickery magic, but that's kind of an indication. That's old school meteorology of how you say, okay, if I'm going to use your model and you're going to be my guidance, do you have a clue as to what's happening? And so you look upstream, and then that affects downstream weather. You forecast from there. But that's a very short-term window forecast. And there's still a lot of massaging and manipulating and guesswork and all that, but at least give you a better idea as to whether or not they have a clue. And then you can go with their output better. Your confidence goes up. Or if they're out to lunch and it's Katie bar the doors or all bets off, or one of these things. So I tell you what, winter weather is challenging. It is fun, but telling you, nobody wants an ice storm. Nobody. We've had some big ones over Oklahoma. We're always lined up for them. It's easier, it seems like, for us to get an ice storm than it is for us to get snow. It's frustrating. All right. Well, I'm going to start to wrap this thing up. I know you guys need to get on with your going to bed business. You might want to check the weather on the news, see what all those guys are going to say here. Weather always comes on at around 10:17 in the evening, by the way. And each station will start at 10:17 because they want your eyeballs, and so they compete directly with one another. And so that's why they're always coming on at the exact same time. Give or take, a few seconds in there. And they'll do it right at 10:17 because they want you to watch that second quarter hour of news so that they can get the ratings for it, so you can watch your favorite guy. Now, when I was a kid, I'd be flipping back over real quick. But back then, there was typically enough seconds difference. Now they don't like you to do that, so they try to get it right at the same time. But regardless, it'll be about a 3.5 to 4 minute weather segment. So typically starts around 10:17. It'll end around 10:21. Then they'll have a break and they'll have sports. So that's how that works. For me, I go on around 9:40 and I steal their thunder. I'll tell you everything you want to know there is to know. That way, at 10 o'clock, you can go to bed. You've already got the forecast. They hate that, by the way. It's just business, that's all. Nothing personal. So, all right. I'm just goofing at this point in time. It's time for me to get out of here, get ready to go to bed. Jody McNeil, you're so cute. My #1 fan. Hashtag Team AT. By the way, if you guys, I try to hit this, but there's so much stuff for me to remember and tell you. When you do get out and get some pictures, whether it goes for the snow or ice or whatever, and you post them in your social media accounts, whether, my page or other pages, your own pages, do a hashtag AT's weather, and that will show up on my website. And it'll be like a big collage of everybody's pictures that show up there. I'll show you what that looks like. Let me go real quick. And then we'll turn you loose. Let's see. Where are we? Dun, 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 dun. So I'm going to go to my news tab. I got local news, international news for weather related. And then I'm going to go to the social media tab. So social media tab, it's where I post all my stuff. It's all... what word am I looking for? Correlated, congregated, co-located. It's a C word, and my brain not working, but this is where they all show up. What is that stupid word? Anyway, here's one from Sharon. She posted, blizzard of 2020. But see, she hashtagged, you see this? AT's weather. And so that will get pulled in from Instagram, and then you can see that here on AaronTotalWeather.com, and all of you guys can be shown here versus just me. And then here's Jessica sporting her AT's weather shirt, which is totally awesome. She's a huge supporter. Let's see. And then there's the rest of my posts from Twitter, YouTube, Facebook, all that kind of stuff. So we can get the AT's weather community going. Just hashtag it, AT's weather. And it's easy as that. If you don't have my weather app, make sure you check it out, AT's Weather to go. You can just search for AT's Weather on Apple, Google Play, and it'll populate there, and you'll be good. All right, well, I do plan on doing a couple other updates for you, so we'll probably do a video update tomorrow night, and I'll try to do one at lunchtime tomorrow, and we'll see what happens. All right, guys, thanks again for your support, and we'll talk again soon. Have a good night.